This is section 10.6, Combinations and Probability. If 3 coins are flipped, how many possible outcomes are there? Well, let's apply a tree diagram. A tree diagram is something we learned about in the first half of chapter 10. If we draw ourselves a tree diagram, we know that on the first flip we could have a heads or a tails. On the second flip, we could have a heads or a tails. And on the third flip, of course, we could have a heads or a tails. By counting the total number of pathways, we see that there are 8 possible outcomes. But now, let's consider the possibility that the order of arrangement didn't matter. How many possible outcomes would there be then? Well, if the order of arrangement doesn't matter, we can classify some of these 8 possible outcomes into a single outcome. Let's take a look. The first possible outcome is that we get all heads. Well, there's only one way that that can happen. The next possible outcome is that we get 2 heads and 1 tail. There are 3 ways that that can happen. But if the order of arrangement doesn't matter, these 3 possible outcomes become one single outcome, the outcome of getting 2 heads and 1 tail. Next, what if we get 1 head and 2 tails? Well, there are 3 ways that this can happen. But again, if the order of arrangement doesn't matter, these 3 outcomes become one single outcome, the outcome of getting 1 head and 2 tails. And finally, the last possible outcome is that you get 3 tails. And there's only one way that this can happen. Now, the discussion of whether order of arrangement matters is the difference between a permutation, which we learned about previously, and a combination. Here's the definition. A combination is an arrangement of items in which no item is selected more than once, and the order of arrangement makes no difference. As I previously stated, this second step here is the difference between a permutation and a combination. If the order of arrangement does matter, then we're talking about a permutation. If the order of arrangement does not matter, then we're talking about a combination. Now, the note at the bottom is an important one. There are generally fewer possibilities if order doesn't matter than there are if order is important. And we saw this in our previous example. If the order of arrangement matters, there are 8 possible outcomes when you flip 3 coins. If the order of arrangement does not matter, those 8 possible outcomes shrink into 4 possible outcomes. Here's the formula for finding combinations. The NCR is read the number of combinations of n objects taken r at a time. That means that we're going to have a total of n objects, and from those n objects, we're going to take r of them and find out how many different ways they can be arranged without the order of arrangement making a difference. The formula goes on to state n factorial divided by the quantity n minus r factorial times r factorial. Now, it's important to note again that combinations can also be done using the combination function of the calculator. This function is located by using the math button and going to probability, also where the permutation function is found. So let's take a look at an example that uses combinations. Anna, Ben, Cheng, and Dina are members of the International Club, and they have volunteered to be on a committee that will arrange a reception for exchange students. Usually there are only 3 students on the committee. How many different 3-member committees could be formed with these 4 students? All right, as we read the problem, it's important that we understand what's happening. We have 4 members of the club. 3 of them are going to be chosen for the committee. And we are being asked how many different committees can be formed. It's not a probability problem. It's important to note that. We have to decide, is it a combination problem or a permutation problem? So the question is, does the order in which our 3 members matter? Well, let's take a look. If Anna, Ben, and Chang are chosen for the committee, is that the same as if Chang, Ben, and Anna are chosen for the committee? The answer is definitely. They're exactly the same. No matter what order you choose the 3 members for the committee, they simply end up on the committee. So the order of arrangement does not matter, and therefore this is a combination problem. So we're going to calculate the number of combinations, C. Now, we have a total of 4 members. We are choosing 3 of those members. So we need to calculate 4C3. And we can use the calculator to do this. So we bring up our calculator, we type in 4, then the math button, and we go over to PRB for probability, and depending on your software, it could be PROB, and we see that number 2 is for permutations and number 3 is for combinations. So we hit the 3 for combinations. We want to choose 3 members for the committee, so 3 and enter. And this tells us that there are 4 different 3-member committees that could be formed. So now we've answered the question, and just to review, it's always important to read the question carefully, comprehend the information, know what is being asked, and then in this case, decide whether a permutation or a combination is the appropriate math used to solve the problem.